Hi, welcome back to Science 1206, the motion unit. I'm Ms. Ledwell, and in this video, we'll discuss position time graphs. Let's get started. Some important points to remember about position time graphs are: the independent variable is time, which is placed on the x-axis. Also, make sure you include your units for time, in this case, seconds. The dependent variable is position, which is placed on the y-axis. Again, make sure you include your units here. The graph should have a title that includes both the dependent and independent variables. On a position time graph, uniform motion is indicated by a straight line with a constant slope. This indicates that the object is moving at a constant speed. A straight horizontal line with zero slope means the object is stationary, not moving. The object's position does not change over time. If we look at the graph, we see at a time of 1 second, the position is 2 meters right. At a time of 3 seconds, the position is 2 meters right. At a time of 4 seconds, the position is 2 meters right. So you can see how the object is not moving. The position stays the same even though time is passing. The slope of the line, calculated as the change in position, rise, over the change in time, run, represents the object's velocity. So the formula for slope is rise over run, which is the same as the change in displacement over change in time, which gives us the average velocity. To determine the average velocity from a position time graph, calculate the slope of the line of best fit. These are the steps you need to follow. Identify 2 clear points on the line of best fit and draw a triangle. Record the positions, the y-coordinates, and the times, the x-coordinates, for these points. Subtract the initial position from the final position to find the change in position. This is the rise, so the change in position is d2 minus d1. Subtract the initial time from the final time to find the change in time. This is the run in our slope. Divide the change in position by the change in time to find the average velocity. Include the direction in your final answer because velocity is a vector quantity. Let's look at an example using a graph. On this position time graph, 2 points have been chosen on the line of best fit, and then a triangle was drawn to help us calculate the slope. Let's look at the steps for this. So the slope is the rise over run, which is the same as the change in displacement over the change in time on a position time graph. I remember rise over run as rise up and run across. That helps me remember which is which. So for our rise up, we went from 30.0 meters to 70.0 meters. When we subtract, we go d2 minus d1. So we have 70.0 meters right minus 30.0 meters right. That's our rise. Our run across, we went from 2.0 seconds to 4.5 seconds. We subtract t2 minus t1. So we have 4.5 seconds minus 2.0 seconds. That gives us 40.0 meters right divided by 2.5 seconds, which gives us a velocity of 16 meters per second to the right. Now it's time to continue to the next video. Pause for a half-a-minute recharge. Rise, reach, and stretch before moving on to the next video.